In this video, I'll explain what is meant by an equivalence class and how to find equivalence class of an equivalence relation. So equivalence class is nothing but every equivalence relation which is defined on a set A gives equivalence class, that is nothing but partitions of the given set. That means for every element of the given set A, equivalence class of A is denoted like this, and it contains all those elements of the set A which are related to A, all elements which are related to A. Set of all x comma A, this ordered pair should belong to the given relation R, then we call that relation, that set as equivalence class of the given set. Let us take one example to understand the concept in a better way. Let R equal to set of all ordered pairs of the form A comma B such that A minus B is a multiple of 4. This is a relation defined on the set A which contains all those integers from 0 to 12. You have to prove first R is an equivalence relation, then you have to find the equivalence class of every element of the set A. Well, you already know that equivalence relation is nothing but it is a relation which is reflexive, symmetric and transitive. So I have to establish the given relation is reflexive, it is transitive and it is symmetric. So for reflexivity, you know that all ordered pairs of the form A comma A should belong to the relation whenever A belongs to the set A. So now this is the condition to say that the given ordered pair belongs to the relation R if it satisfies the condition A minus B is a multiple of 4. Suppose if I want to prove that A comma A is there in R, I have to check is A minus A multiple of 4. Yes, A minus A is 0, which is a multiple of, clearly 0 is a multiple of 4 because 4 into 0 gives you 0. So therefore this A comma A belongs to R for all. Whatever value of A you take from the set A minus A equal to 0 is always a multiple of 4. Therefore this condition is satisfied. Whenever this condition is satisfied, the corresponding ordered pair will belong to the relation R. Hence it becomes reflexive. Now for symmetry, I will take to one ordered pair of the form A comma B belongs to R. If there is that is in the relation, then it satisfies A minus B is a multiple of 4. If A minus B is a multiple of 4, then I can write A minus B as 4 into some integer k, where k belongs to Z. Now take negative on both sides, multiply by minus on 1 on both sides, then we'll get minus of B minus A. Definitely that is also multiple of 4. That is mild 4k1 you can take, that is after multiplying 4k minus 4k, then b minus a, which is equal to 4k1, it is taken as 4k1. So b minus a is also a multiple of 4, therefore B comma A also belongs to R. Hence it becomes symmetric. Then for transitivity, take two ordered pairs of the form A, B and BC. If A and B are there in R, A minus B is a multiple of 4. B and C there in R means B minus C is a multiple of 4. So A minus B can be written as 4 into K1. B minus A as 4 into K2 because they are all multiples of 4. K1, K2 are some integers. Then take the sum of these two, A minus B plus B minus C, 4k1 plus 4k2, B cancels, 4A minus C equal to 4 into k1 plus k2. Take it as a new integer k3, that is also multiple of 4, therefore A comma C belongs to R. Hence we have shown that A is reflexive, A is symmetric and A is transitive. R is reflexive, R is symmetric and R is transitive, therefore R is an equivalence relation. Now we have proved that R is an equivalence relation on the given set A. You know that one equivalence relation always generates an equivalence class or partitions of the given set. Let us find out the equivalence class of every element of the set A. A contains elements from 0 to 12, so on up to 12. Let us find out the equivalence class of each element one by one. The equivalence class of 0 is nothing but set of all x belongs to R. X belongs to A actually, the set A, such that x comma 0 belongs to R. The elements which are related to 0, that is set of all x such that x minus 0 is a multiple of 4. It's nothing but x is a multiple of 4. So 0 is a multiple of 4. The elements 1 is not a multiple of 4, that won't come. 2 is not a multiple of 4. 3 is not a multiple of 4. 4 is a multiple of 4, yes, that will come. Then 8 minus 0. 8 is a multiple of 4. 12 minus 0, 12 is a multiple of 4. These many elements will come in equivalence class of 0. So equivalence class of A always contains the element A. It is always non-empty because that particular element always belongs to the given equivalence class. Equivalence class of 1 equals, set of all x belongs to the set A. It should be A everywhere. Such that x comma 1 belongs to R, means all those elements which are related to 1. When the elements will relate to 1, only if they satisfy this condition, x minus 1 is a multiple of 4. Now 0 minus 1, starting from 0, 0 minus 1 is not a multiple of 4. 1 minus 1, 0 it gives you. 0 is a multiple of 4, therefore 1 comes. Then 2 minus 1, 1 is not a multiple. 3 minus 1, 2 is not a multiply. 4 minus 1, 3, not a multiple. 5 minus 1 gives you 4, 4 is a multiple of 4. Therefore, x equal to 5 satisfies the condition, 5 will come. Similarly, 8 minus 1 gives you 7, 9 minus 1 gives you 8. 8 is a multiple of 4. So, those elements will come in the equivalence class of 1. When you are calculating equivalence class of 2, it is x minus 2 is a multiple of 4. That is starting from 2, 0. 0 is a multiple, 4 is a multiple, 8 is a multiple, 12 is a multiple, and so on, like this. So, with the number which gives you 4 as the answer, 8 as the answer will become the multiple of 4. So, if you put x equal to 2, it becomes 0. So, 2 is a value of x. If you put x equal to 6, the 6 minus 2, 4, it's a multiple of 4. That is satisfied. So, x equal to 6. Then x equal to 10, 10 minus 2. Therefore, this is the equivalence class of 2. Equivalence class of 3 is x minus 3 is a multiple of 4. That is 3 minus 3, 0, 3. Then 7 minus 3 is 4, multiple of 4. Therefore, 7 will come. 11 minus 3 is a multiple of 4. Therefore, 11 will come. Other elements we don't want because A contains elements only till 12. Now, if you go for calculating equivalence class of 4 the same way, then x minus 4 is a multiple of 4. Again, that 4 will come. 0 will come, 4 will come, because minus 4 is a multiple of 4. If you put 0, then 4 minus 4 equal to 0 is a multiple of 4. Then 0, 4, 8 is a multiple of 4. 8 minus x equal to 8 is 8 minus 4, 4, which is a multiple of 4. Then 12 minus 4 is nothing but 8 multiple of 4. The same equivalence class, that is same as equivalence class of 0. So if you continue with the equivalence class of 5, that will again repeat because these are the distinct equivalence classes we got. So what is meant by equivalence classes? Nothing but it's partition of the given set. So given set contains elements from 0 to 12. Now this particular equivalence relation, the equivalence relation R is nothing but the equivalence relation R is set of all ordered pairs of the form A comma B such that A minus B is multiple of 4. This particular equivalence relation now divides the entire set into 4 partitions, one containing 0, 4, 8, 12, that is equivalence class of 0. This is 1, 5, 9, equivalence class of 1, and this is equivalence class of 2, and this is equivalence class of 3. Any other equivalence classes, they are all one among these 4 equivalence classes. So this is meant by equivalence class. So only if there is an equivalence relation on the given set A, then we will get the equivalence class. And equivalence class is not unique. Based on the given relation, the classes of the elements will change. For this particular equivalence relation, we have this particular equivalence class. If you change the equivalence relation, then you will get different partitions of the set. Partitions are not unique for the given set. This is all about equivalence relation and the equivalence class induced by the equivalence relation. I hope you understood the concept. Thanks for watching.